Well, Jeff's an honorary, like I said, he's an honorary member of our club. He's been doing stuff, like he said, since he was 5. So he's going to do a presentation on antennas, and he's got some fancy ass analyzers up here. That's all I can say. So come on up, Jeff.
That is true. Thank you, Aaron. In fact, I've got an article that I wrote. I'm going to pass these out. I wrote this article for CQ magazine. They're not even around anymore, but that's a little history since I was 5. And I used to talk with my dad to Uncle Dick, who was in Santa Monica, and I just thought ham radio was the coolest thing. We had our crystal controlled LMAC AF67 AM transmitter and this S40B receiver, and I just was in heaven when we're talking to Uncle Dick. And I have never let go of this hobby. This has just been the most fun thing I've ever done. And over those years, I've been in the tech business like Brian has over here, and I have acquired an awful lot of tech stuff. Most hams don't ever get their hands on this kind of stuff. I've got what's called a field fox right here. These start at about 10 grand and go to 40. And what this does is it's a network analyzer and a cable analyzer. It analyzes everything. Tonight, I'm going to show you what handheld antennas look like when it comes down to resonance and SWR. It's going to shock you. I was at Pacificon, and we set up a little sign there and said, check out your handheld antennas. And so guys would come on and they'd screw their little Anytone antenna on and found out that their SWR was 11-to-1 on UHF, and it was 6-to-1 on VHF. And if you start thinking about that, that's pretty bad. If you're running 5 watts with an 11-1 SWR, you're probably putting out about 1/4 of a watt when you sit and think about it. So I had a garbage can sitting next to my little demonstration thing, and it was filling up with antennas, and they were going over to HRO, Jim, and they were buying real antennas and sticking them on there and going, oh, this thing really works well. So I've been thank you. I've been really surprised at some of the really cheap antennas are awesome. Some of the ones you buy that are pretty expensive are not. And we'll be doing a little bit of playing with that. I'd love to have you guys come up and get your hands on this stuff. You're welcome to come in. I normally bring duplexers and all kinds of stuff, but the big problem with this kind of equipment is you can get into the weeds really quick. And to the point where you don't even understand what you're looking at. And I've had this happen to me a lot with these guys. The Field Fox, one thing that they do, just think about this function that I blew my mind when I first heard about this. Say you work for a broadcast company. I work with K-Love Radio, and they've got 1,000 transmitters. This guy, you can put in 10 frequencies into it. You jump in your little Volkswagen with a rubber antenna and start driving around. And when you're all finished, it will give you a system map of the signal level of every one of the transmitters. Just think about that, right? So it's actively listening to all 10 frequencies and charting every location, and it comes up with a map and says, here's your map, here's where your hot signals are for every single one of your transmitters. That's what this technology is today. It's crazy. The other thing you can do is you can put a piece of coax on this and tell it, go do an autocal on this piece of cable, and it will tell you exactly how long it is down to the inch. But it also calibrates itself as if you're hooking an antenna to the top of the analyzer. Does that make sense? So in other words, it goes out and tells you all the details, the velocity factor of the cable. It can even guess what kind of cable it is. But it will tell you, say it's 100 feet long, so you got 100 feet of cable. But instead of being able to plug the antenna right in the top of the analyzer, you can't. So what it does is it goes out and compensates for it and says, okay, now I'm measuring from the end. Now you can hook your antenna up, and it compensates for the cable. You obviously have loss in your cable. And so that can be confusing. If you got 3 dB of loss in the cable, when you calibrate the cable with the Field Fox, it says, forget the cable, I've just taken the cable out of the equation. Now we're gonna start from the end of the cable and work toward the antenna. It's very, very good at finding problems in antennas. It will tell you, if you take a I had a piece of heliax on one of our antennas one time, had a little ding in it. And I mean, it was small. How about an inch, a 1-inch cable, and there was about a 1/16 of an inch little poke in it. And it found it and said, at 76 feet, there's a bump in your impedance. And you measure out 76 feet and you'll see what it was. That's how critical some of this stuff is. So right here, and I don't know if you guys can see this. This analyzer, this spectrum analyzer is what's on the screen. This guy right here. This is going to be a little difficult because me standing near this antenna affects it. But what I'm looking at right now is this little antenna right here. No, I'm sorry, I'm looking at this guy. This is a really expensive antenna. This is from a broadcast receiver. It's a $250 rubber duck. And you can see, it is, if you can see this, and if anybody wants to come up here and look at this, feel free. It's resonating right now at 490 megahertz. Well, that's the center, and it says the SWR 1.02, pretty hot. As I start moving the frequency around, you'll see the SWR start going up, and it'll tell you if you're off by 1 megahertz or whatever it is. This particular antenna has a range, I think it's 470 to 512. And so we can tell exactly by putting it on here, and getting my hand near it and touching it doesn't affect it very much. Now, you take a ham antenna, we'll screw that on here. This particular antenna I'm going to put on here is made by Retivus. Is that a real company, by the way? Yeah, is it Chinese? Okay, all right. So, can you guys see this at all? Get a little look at it. Oh, that's kind of, yeah, that'll help, huh? Let's put the water bottle back here. Like I said, this is a little difficult with this thing, but so you see the start frequency I have is 271 to 741, and you see two dips right here. It's resonating at both those locations. So antennas typically will resonate at twice the frequency and on the primary frequency, and sometimes we may be too high. I'm going to try 144. So let's go from 140 megahertz to, I see something there, to 160. Let's do that. Okay. Now, see when I get my hands around this thing, it kind of starts to go nuts. There's a little marker right here, and I'm going to say, where is the center? Well, right there in the center. Now, see me moving away, and it's changing on me? The point is, it's not resonating well at the ham band. It's right at the ham bands right now. It's actually at 150 in the center. Well, what does this do when you're on a handheld? Especially a VHF handheld. You got a VHF antenna on there? SWR is all over the map. And I had an explanation from a couple of good repeat owners, like I am. And the feeling is they're so high in the air and the receivers are so hot, it doesn't matter what you're on, it's going to hear you. But some antennas are better than others. Stock antennas on an Anytone, I would throw the thing in the trash and just go get a real antenna. But then at the same time, I've gotten some Anytone antennas that have been perfect. So, and it's not as critical on UHF because the width of a UHF signal is much shorter. So if you're near it, it doesn't affect it quite so much. But VHF, man, you get anywhere near it and you can see it starting to move around. I was at Pacificon and a guy brought me a CB antenna that was about 6 feet long, a rubber antenna for a CB handheld. We threw it on here and the SWR was horrible. And I said, now watch this. And I just touched the bottom of the connector, which made me the ground plane, and it was perfect. So we can talk about ground planes here a little bit. I just saw the music stand here and I was thrilled because this is a perfect ground plane. So let's try something here. Here's a little, I don't even know where I got this antenna. This probably came from a swap meet somewhere. And the guy told me it was UHF or something, I don't know, whatever it is. You can make a liar out of somebody pretty quick with the field fox. All right, Let's find out where this thing is resonating. But to find out, we're a real short bandwidth here. What are we at? We're at, what frequency are we on? We're at 140 to 150. Let's go 140 to 800. Let's make the high end 800 megahertz. And again, I want you guys to come up here. Ooh, see that right there? All right, let's go find a frequency. Let's find out what it is. I'm gonna push the measure button here and say now, there's a little marker right there. Got a little resonation going on at 196, okay. What's the second one up here? 541. They're both 1.1 to 1 at those frequencies. Let's go pick the 5. Well, okay. How do you figure out what frequencies this should be on? This was on your test. Anybody know? What's the formula? You got 468 over the frequency, right? So how do we figure out, this looks to me like it's not 2 meters. I don't think it's quite long enough for 2 meters. Brian, you're a veteran. How long, what frequency is that on?
Does it have any loading on it?
No. I'm glad you brought this up. This is a pet peeve of mine. You get these dual band antennas that have perfect SWR across the ham bands, but you stick it on the field fox and it says it's resonating at 138 megahertz. What's the deal? The deal is they put coils and caps inside these things to make your radio happy, to make it look good, but it's not always good. There is no perfect antenna. I hate to break that to you, but you can't buy a perfect antenna. It doesn't exist. Anyway, let's just shoot for this one here. What's the SWR 1.13? All right. What happens when I just stick it on the table? Well, that went down the tank in a hurry. So is it good to have an antenna and just stick it on a table someplace, or do you, even a cookie sheet, a metal cookie sheet is pretty awesome. Because, how about that? Any questions so far?
So what is the primary resonance on that?
On this antenna? Well, that's a great question because it's resonating in 2 spots and they're both good. So Brian, I can't tell you that. I'm not sure. It's resonating there at 541. I'll move it over here. It's resonating also at, I think it was 200, something like that. 196. It's a 220 antenna, I'll bet. Right? Yeah. Now, here's the other thing you can do. Let's say it says 196. I'm going to make the center frequency of this 196 now. Let's do that. 196 megahertz. There it is right there. Now, I'm going to say span this out so it's wider. We're sweeping here from, oh nice, from 2 megahertz to 390. Let's make this a little wider. The span right here. Oh, come on. I have to really think when I'm doing this. I want that at 196 or 199. Okay, that's good. 1.1 to 1 right there. Now I can tell it, let's go, in 199, let's make it 170. We'll go from 170 megahertz. Okay, and we're going to go to 180. No, I'm sorry, 200. So we'll make the high side 200. All right. Well, that gives you a little better idea. Here's the marker right here. Marker says, turn the marker on. We're at 196 right there. Now, if I move up to 190 or down to 192, we're up to 1.3 to 1. And we keep moving. You see the value of a field fox? You can just climb right up the waveform and tell exactly what it is. Right now, 184 megahertz, we're at 1.7, and it gets worse. So what's that tell you about ground planes and antennas? Kind of important. You definitely want to have this on the top of your car or something like that. You don't want just an antenna flying in the air, but that goes right back to the handheld discussion. You need to be carrying around Yeah, how about a cookie sheet? Just, or put it on your head or something, right? You got the best coverage. All right, so let's switch over to this other thing. Any questions on the Field Fox so far? Did I totally bury you? Did you understand that? Are you a new ham or you're becoming a ham?
I understood almost none of that, but I'm trying to absorb the osmosis.
You're at the right place. Yeah. And when I was a young kid, I was just like you. Yeah. Over my head, right. And my dad kept telling me, do not touch the transmitting tubes, and I burned myself so many times. Have you guys ever been hit with 2 kV, a couple thousand volts, reaching into your Heathkit SB200 amplifier? And it was shut off, and it was unplugged, but I still got hit. I learned that lesson so many times. Wow. It's amazing that I'm alive. I've had 3 cardiac arrests and died 3 times, and my wife keeps saying, I know why this happened. You're a ham radio mess. She's convinced if there's an antenna anywhere near her, she's going to vaporize. And so we don't have antennas at our house for that reason. So that gives you a look at that analyzer. There's a lot more that it does. There's a lot it does that I don't understand, and I've had this for a couple of years.
Would you explain to our new friend why it's important for this antenna to be resonant?
Yes. So here's the deal. When you're putting out a signal you're transmitting, and it's not as critical on the receive side as it is on the transmit side, but you want to make sure you get the maximum transfer out of that transmitter into the antenna and into the air. That's our goal, right? That's the important part. But the more SWR, the more reflected power that comes back down that antenna and into the radio, the less power you're actually putting out, and it's starting to threaten your radio. That's why they have all these fallback circuits and all that stuff in there to protect the radio. Never think of it this way, but you know what? It protects the radios from us being stupid. So you get a good 100-watt radio, you can boil that thing pretty quick with the wrong antenna. And so it's super critical. The SWR is, but on the new handhelds, all of them are so protected, you're not going to break the handheld, but you're not going to put out much signal either. So anyway, does that make sense? You want to get the maximum power transfer from the transmitter out to the antenna. Did I lose you guys on the whole coax thing? You even understood that? Oh, yeah, okay, cool. Cool. So coax is how you get that signal from your radio out to the antenna. Sometimes it's a couple of 100 feet. That's really critical too. You want to make sure you've got good coax and that it doesn't have reflections and all that. Go ahead, Brian.
So when you're taking a measurement, do you measure at the antenna feed point or as close to it, or do you measure down the coax that you're actually going to be using in your install?
Okay, so did you guys hear the question? So do you measure it up at the antenna or do you measure it down at the coax? It depends on what you're trying to do. If you're trying to see, is this going to blow my transmitter up, you measure it down at the coax because that's what's critical to the radio. The radio needs 50 ohms. Man, should I go into the Smith chart thing? Anybody want to know about Smith charts? No. Smith charts are really easy, but people make them too hard. Well, I can show you why they make them too hard. I'm going to show you a Smith chart here. This boggles my head when I do this, so hang with me. I'm going to ask it for a Smith chart of this thing, and you're going to go, tell me what that is. You see that little thing right there? It's a bit of a mess. So look, here's the deal. I'm going to clarify this real quick by putting a dummy load instead of this antenna. This is resonating pretty good. Okay, we're good. But I'm going to stick a dummy load on here. What you see is there's a dot right in the center. What that's telling you is from the start to the end frequency that we have plugged in here, which I think was what was it, 180 to 2 something. It's at 50 ohms. 50 ohms is right in the center. And it's looking at your start frequency to the end. You saw that curly Q going like this. One end of that curlicue was your start frequency, the other was the end. And as you travel along that frequency, it will tell you why it's out and how far it's out. Okay, did that make sense? Or did I totally lose you? Let's put it in again. Better yet, I'm going to plug this in. You want to get your mind bent here a little bit. That's actually not as bad as I thought it was. But you see, now it's over here. But it's telling me at this frequency, we're at 97 ohms. Your radio's not going to survive that. And so if you put a dummy load on it, it's going to tell you along most dummy loads will go up to 1,000 megahertz. No matter what frequency range we put in there, it's going to be a dot right in the center because it's 50 ohms across the whole band, whatever you're on. So when you put an antenna on this, let's go to the HF band, not the HF band. I'm sorry. Let's go to the VHF band. Let me get out of this. Oh, come on now. There we go. I confused myself totally. All right, let's go from 140 megahertz to 180 megahertz. That should cover the 2-meter ham band. All right, so it's changed a little bit. And I'm going to turn on this marker. This marker's that little yellow mark. And if you guys can see that, you're really good. See it moving? All right. Look at this. We're at 167 megahertz, and we're at 105 ohms. We're getting closer. Let's keep going. Where's it at 50 ohms? Right about there. It's 46 ohms at 151. What's that telling you? That's telling you that antenna is pretty good on VHF. But you'll see it change a little bit. When I come near it, yeah, it's changing. So now let's go into SWR again. Okay, well, it's even changing here. But so that's a UHF, VHF, Chinese antenna. Not too bad. It's actually better than most. I had a lady come up to me, I had a lady come up to me at Pacificon, and she had this pull-out antenna, just an extending antenna, and she said, try this, and I did. And crazy enough, on UHF it was perfect, and it was perfect on VHF. Where did you get this? And she said, Amazon. It's a dual band antenna for $8. Wow. No, it's not. I was actually very impressed. It's not. The Field Fox will tell you that. So anyway, so you see there's a dip here, and that little dip, where's that end up? 153. I'll take it. Yes, go ahead.
So if you added a piece of coax to that, that was not a resonant length or an odd multiple of 8 or whatever you want to throw on there, how will that affect that Smith chart reading? Because as you move farther away from that resonant.
Yes. So let's get back to the Field Fox calibrating at the end of a piece of cable. You asked which end do you measure it at? Okay, if you tell the Field Fox, I want to measure it from the end, it's going to take all of the crud in the middle and say, forget all that, we're going to measure it from the end. That's how intelligent this thing is. And then you're looking just at your antenna. But the bad news is say, now look at the other end, look at this end. And it's going to say, you got a mess going on. You got a crimp in the cable 75 feet out there. But it allows broadcast engineers mainly to look up a piece of cable. They turn the transmitter, the 50 kW thing, they turn that off. But yeah, they can look up the cable and they can see a problem and where it is. And so, super valuable. Speaking of that, you're going to read in that little paper I sent you guys. When I was 15 years old, I was licensed at 10. And at 15, a friend of mine, his dad worked and ran Voice of America. You know this story. In Dixon, they ran 500 kW there. They had rhombic antennas that were a couple of miles long. and they were off the air, and his dad took us through a little tour of the transmitter. I said, this is awesome. He turned the thing off. We walked into the power supply room, the transmitter room. You can actually get inside the tubes. They were that big. You got that much power. When we were all finished, he fired it all back up and said, let's get on 20 meters. Excuse me? Nice antenna. And so he gets a Collins KWM2. He hooks it up to the transmitter, and the band was completely dead on a rhombic. There was nothing. And we were running 500,000 watts on a rhombic pointed north. And we called CQ, and a guy in Alaska answered. And the first thing out of his mouth is, damn, you're loud. Where are you guys? Oh, we're down in California. Yeah, we can barely hear you, dude. And can you tell me a little bit more about your transmitter? Nope, see you later. At that age, I was convinced that the FCC was sitting right outside that door and I was going to get arrested. But obviously, you know, got a little more wisdom these days. I would not recommend you do that. And you know what? They're off the air now, so it doesn't matter. Okay, so let's get over to this other guy. Let's forget the Field Fox. Over here, I've got. That is a bandpass filter. And it says on it 947 megahertz. Well, let's look at this. Okay, so I'm going to push in the frequency. The center of that is at 750 right now. And so what you're seeing is that we're using this filter. We're putting a signal out of the generator on this spectrum analyzer. So this is not a Field Fox. This is a spectrum analyzer. The Field Fox is a network analyzer. Two different kind of things here. Our center is 750 megahertz. Our span is 52. So from here to there is 52 megahertz. This is how you filter out garbage around your repeater. You put in a filter, and it's letting that frequency through, and everything on either side. The goal is to make sure it doesn't get through. So on a receiver, we just did this on 4.3, right? And did you using that filter?
Yep, it's installed at Georgetown.
How many cans did we use?
3.
Okay. So this is one you're looking at right here. You see where it hits right there. When you put a second can in, so you daisy chain these guys, and we have 3 of them up there. When you have 3 of them, this gets even sharper. Instead of like that, it comes down even tighter and tighter. The bottom line and the problem with it is if you put too many of them in there, you start having loss. You have loss anyway. Every one you add, you have a little bit of loss, but on receive, it doesn't make too much difference. It's not too bad. Anybody know the 3 dB rule? For every 3 dB of loss, your signal gets cut in half. Okay, on the transmit side, that's critical, critical, critical. If you have 3 dB of loss and you put in 100 watts, you're gonna get 50 out of the other end. So every 3 dB, it cuts in half. If you go to 6 dB of loss, you're half of that, you're at 25. But think about it on the receive side. You've got a signal that's 1 microvolt, and so you have a loss of 3 dB. Well, instead of a microvolt, it's gonna be a microvolt and a half. Is that right? Hang on. The other way. A half. Thank you. Every 3 dB, it's a half, right? Does that make sense? That's why it's not quite as critical on the receive side as the transmit side. So when you're building a duplexer for a repeater, you've got one antenna, usually 3 cans on each side. One lets the transmit side through, one lets the receive side through, or the transmit side out. So let's not get in the weeds, but that's how these work. So you're looking at that kind of a filter. Now, if you come over here and you turn this, so you can see it has just a single plunger. What's going on here? I just moved the frequency of the filter. It's just a can inside with a brass or copper plunger inside that's moving. and it makes a tuned filter. So this is how you can really screw up somebody's repeater when you go in and just start screwing all the cans down. That'll really mess everybody up. So right now, if I look at the frequency, and I'm gonna go say, where are we here? You put it in the center. 760? Yeah, so that's how you tune these filters. This is easy stuff if you got the right gear. Any questions? Or you got it all? Nobody? We're going to do another tech day at our office. This is just a little bit of the test equipment we have. So tech day, we open up our entire warehouse and you get to walk through there. And a lot of times, if you need something you see, you just get to take it. That's what kind of a cool thing. We have a junk box there. You've been around the junk box. Yeah, it's the size of a pallet. And every time we have a piece of gear we just don't need or cable or whatever, we pitch it into the dumpster. We don't ever throw it away. We just call the hams. And the funniest part is when they come in the door, all I see is butts because they're all inside dumpster diving. And it's pretty fun. We serve hot dogs, hamburgers, and all that. So we're going to do another tech day. I'll let you guys know when we're going to do that, probably another month or so. And we're going to try to do it on a Saturday this time. We normally do it on Fridays, but we're going to try to do it a Saturday. Who's invited? Everybody. Yeah, everybody's invited. Anybody know what a Hammond B3 organ is? Yeah? I have 2 of them. And I'm in the process of refurbing both of them right now. We're going to donate one to somebody, to some church or something, I think pretty quick. But that's been one of my really fun things to do is dig into that thing. It's the most amazing piece of gear I've ever seen. That trumps ham equipment on my book. But anyway, sorry about the word trump. Anyway. Okay, ready for break time or any questions? I mean, I don't have much more unless you guys want to come up here and get your hands on this and start tweaking. You can turn anything you want and I can get it back out. So, hang on, Brian's got something.
You have your Field Fox. We have our NanoVNAs.
Yes.
What can we do with the NanoVNA?
I want to do another class on NanoVNAs. It's a really cool little device. It does a very similar thing on the Smith charts, but it's normally when you get to that screen that you go, what the heck am I looking at? And what you're looking at is you're looking at impedance. Impedance is a critical piece, but I didn't understand impedance until I was 50. So don't feel bad if you don't get it. But that's why 50 ohms is important. 50 ohms is important. Your radio is 50 ohms of impedance on the receive and the transmit side. Your coax better be 50 ohms also, right? Not just the coax, but the antenna, everything in between needs to be 50 ohms. And not everybody has this kind of equipment to figure out, is that where it is? I've seen some pretty good commercial antennas, and you put them on a Field Fox and it says that's at 40 ohms. Well, even the antenna manufacturers probably don't have some of this gear too. So, does that make sense? So I'd love to do a class on the NanoVNA. Yes, Jim.
So you mentioned that the Field Fox, among other analyzers, will do things that'll tell you where a break is in the cable. Is that time domain reflectometry that's doing?
Yes.
Very nice.
Yeah, and basically it sends a signal down the coax, and then that gets reflected back unless you put a dummy load at the end, and it will not be reflected back. That actually will confuse a Field Fox, right? You put a dummy load at the end, there's nothing to reflect because it gets 100% absorbed. You got a great antenna and everything is right, all your coax is right. It'll send a signal out and nothing comes back. How does it work? How it works is you got a little ding in the coax somewhere. When that signal gets out there, it sees that ding and it reflects it back. The TDR, time domain reflectometer, the Field Fox, all these devices measure that time looking at the speed of light and saying, that is 73 feet from me. That's how they work. That answer your question? But that's exactly what it is. Tektronix used to make a TDR that you hauled around with you and all that.
The rest of us made something called the Rig Expert that does just that.
Sure. They all work the same way. There's no magic in what they're doing, but they all work the same way. So Anyway, that's what a TDR is. But there's some other great gear that we have that you get to play with. And if you want to bring your radio and you want to check it out, it's awesome. Yes.
You were going to talk about tiger tails. Should we put a tiger tail on our HTs?
A tiger tail. I've never heard of a tiger tail. I would say, where are you? Are you standing under the repeater or are you standing 30 miles away and trying to get in? Yes. Yes. Why? You just saw a demonstration of why. It's this concept right here, right? You got to have a counterpoise on your antenna, especially these F antennas. You got to have a counterpoise on them or they're not efficient. What happens? Their impedance changes, for one, and that's a big deal. When the impedance changes, you're not getting that transfer of energy like you need to. And so it's a magnetic, well, this is aluminum, but it's a magnetic mount. It's made that way for a reason. So you can stick it on something and you've got your counterpoise here. And like I said, it can be a cookie sheet. It doesn't matter what it is, but it'll improve your reception and your transmission both pretty quick. Yes, sir.
When it's used in the TDR mode and you have a run of cable that might have, say, a couple of splices in it, if the splices are done correctly, will it show any reflection or not in something like that?
Absolutely.
It still will show.
Yeah. When I get into these details like this, I get into these classes where I show connectors, get the best quality connectors you can, end connectors, and barrels. Put them on the field fox and it'll say there's something bumping the impedance right here, may not be critical, and there's another one here, and then I see the antenna at the other end. And so yes, it is critical, and you want to use good connectors. I got a couple of Chinese connectors here that I'm not very proud of. There's one, and it looks like it's gold plated. I doubt it. That's a really cheesy connector. If you buy the equivalent of this from Amphenol or something, it's probably $100, right? And this is, I think, $1.98. But be careful using this cheap stuff because, and the Field Fox doesn't lie. You can't tell by looking at it, it looks okay. But you have no idea until you stick it on a piece of equipment that says, no, that's not what you think it is. Just like this, your $200 rubber duck. There's no rubber duck in the world worth $200 until you look at this and go, you know what? That thing resonates perfectly. It doesn't even get affected when I'm standing around it. It's a pretty good antenna, right? So you get what you pay for. All right. Anything else? And I'll let you guys know when we're having Tech Day. You'll never have more fun. And I tell you, they tell more tall stories there than anything. There's a lot of bragging going on. So anyway. There you go. Thank you, guys.